Hi and welcome. So today we're going to be talking about Chapter 13. Chapter 13 is all about definite integrals. Today, as our assistants, we have over to the side, we have Ariana, and we also have Franklin down here. And just behind the camera is little Anne, who is quite the rare sighting. And below the table over here, we also have hidden in the back corner Midnight. All right, so lots of assistants today, and I hope that they'll all be able to help you to understand what's going on in today's video. All right, so we're going to start with an example. Now, I do have a title here of area under the curve, but that doesn't necessarily relate to this example as it's written. And so our example starts out with a coal mine produces 25 tons of coal per day. How much coal did the mine produce from day 2 to day 7? Now, if we were in class, I would ask you to think about what your answer would be to this problem, and then talk to your neighbor about what your answer is going to be. Okay? So we're not in class, so what I'd like you to do instead is to pause the video and take a minute and think about how you would answer this question. We have a total of 5 days, and each day the coal mine produces 25 tons of coal. No, really. Pause the video. Okay, so we're back now. Okay, so probably what I'm hoping that you did when you did pause that video, right? What I'm hoping that you did is that you thought about an answer that maybe looked something like this. Well, we have 25 tons of coal per day, and there are a total of 5 days. And so 25 times 5 gives us 125, and that would be tons. 25 tons per day times 5 days gives us 125 tons. Cool. Now, you may have thought, well, it has to be more complicated than that. And, well, the answer here is no, it's not. It's not any more complicated than this idea of 25 tons of coal per day times 5 days gives us 125 tons. Okay, now, this is a perfectly fine answer. I want to suggest and describe a slightly different way of thinking about this particular problem. And it may seem a little bit strange for me to think about this, but or for you to think about it in this way, but hang on and follow along with what I'm talking about. Okay, so we're going to consider this perspective. I'm going to draw a picture. And this, well, it's a graph. And what I'm going to do is I'm going to draw a horizontal line at a height of 25, and that's representing this 25 tons of coal per day. So along the y-axis, we have tons of coal per day. And on the x-axis, I'm going to mark off the number of days. So we have 1, 2, 3, 4, 5, 6, 7, etc. Okay. All right, now this horizontal line that I've drawn here is actually a function, and what that function is that is a function that is describing the amount of coal that the company is producing each day. So in other words, the coal mine is producing 25 tons of coal per day. That is the rate at which they are producing coal. So this 25 tons per day is the rate of coal production. Now, when I see words like rate or rate of change, I immediately want to think about derivative. So another way to think about this 25 tons per day is to think of this 25 tons per day as a derivative. So maybe I'll call that derivative f prime of x. And so f prime of x represents the rate of change of the production of coal. And in our case, f prime of x is equal to 25. Okay, now the next thing that I want to consider about this picture is we are asked how much coal did the mine produce from day 2 to day 7. So I'm going to draw a vertical line here at day 2 and here at day 7. And what I want to notice about that, is that I've created a rectangle here. And if I shade this rectangle, I can kind of look at it. And what I might observe about this rectangle is that the width of this rectangle from 2 to 7 has a width of 5, and the height of this rectangle, well, that height is 25 because the rectangle started at the bottom at y equals 0 and goes up to 25. So the area of this rectangle is, well, let's see, area of a rectangle is length times width. So we have our length of 25 times our width of 5, which is 125. And what you also might notice about this number is that the 25 is in tons per day, and the 5 is a measurement in days. And so if you think about tons over days times days, the day cancels, and that leaves us with a label of tons. Okay? So what I want you to take away from this perspective is that the area under our derivative between day 2 and day 7 represents the total amount of coal produced during that time period. So I'm going to write that down over here. The area under f prime of x between day 2 and day 7 represents the total amount of coal produced from day 2 to day 7. Okay, so under this function and above the x-axis, this area under our derivative represents the total amount of coal produced. All right, so we're going to look at a similar example, but you'll notice one big difference. So in this example, the rate of production of coal is f prime of x equals 100 e to the negative 0.1 x tons of coal per day. The question is, how much coal did the mine produce from day 2 to day 7? Okay, so in our first example, we were told that the rate of coal production was 25 tons per day. But here we have something that our rate of coal production changes depending on the day. So it might make sense for us to take a look at what this graph looks like. So you might want to graph this function on your calculator. I did this ahead of time, and this is the graph that I got, and you should maybe double check that you get the same graph that I do. But the picture looks something like this. And this graph crosses the y-axis at 100, and this is a graph of f prime of x equals 100 e to the negative 0.1 x. And this function is representing the rate of production of coal in tons of coal per day. So our y-axis is tons of coal per day, and our x-axis is representing number of days. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are days. Okay, so what this graph is saying is that every day the amount of coal that is being produced per day is changing. Maybe here on the first day, they are producing 100 tons of coal on that day. On day 3, they are producing less coal per day than they did on day 0. Okay, now our question is, how much coal did the mine produce from day 2 to day 7? The problem is that before we had 25 tons of coal per day. And we could take 25 times 5 days, and that gave us 125 tons of coal. And that was great. But here, because our rate is changing, the how much coal is produced per day depends on what day it is, we can't use that sort of multiplication idea. But what we can do is that we can use the idea of area under a curve. And so if I draw a line here at day 2 and a line at day 7, then the area that is under our function and above the x-axis, this area, if we can calculate the area of this shaded region, that will tell us how much coal is produced from day 2 to day 7. And that's an important feature, so I'm going to write that down up here. So the area under our derivative between x equals 2 and x equals 7 tells us the total coal produced between those days. Okay. Now, it turns out that this area in here, it turns out we're going to be able to calculate that area, and that area happens to be equal to, and you wouldn't know this answer at this point, but you will by the end of today and our next class, that this area is 322.14 square units. And because our graph is a rate of change of coal, the area under this graph tells us how much coal is produced. So this area being 322.14 square units tells us that from day 2 through day 7, 322.14 tons of coal were produced. Okay. So I'm leaving you with a couple of questions here. One of the questions is, how the heck did I come up with that number? We're going to figure that out, and we're going to learn about that. And number 2, I want you to think about this idea of, if you have a derivative, the area under the derivative from a starting point to an ending point tells you something about total change. So I'm going to write that part down as well. In general, area under a derivative, where that derivative is called f prime of x, tells us the total change in the original function. Between your starting x value, which I'll call x equals a, and your ending x value, which I'll say is x equals b. Okay. Now, in your remote assignment, one of the questions that you're going to be asked about is you're going to be looking at a picture of, you're going to have a graph that looks like this, sort of, and along the x-axis you will have days, and along the y-axis you will have number of cases per day. And we're talking about COVID cases here, and so the number of cases per day is this graph right here, which is the derivative. How is the number of cases changing? Okay. And so when we say we want to look at the total number of cases from day 10 to day 30, I would start at day 10, I'd end at day 30, and the area of this shaded region would be the total number of cases from day 10 to day 30.